In this video, we're going to solve a maximization problem graphically. However, we're going to use Desmos. So I'm going to teach you how Desmos can be a tool when solving these maximization problems. So you've done it by hand, you've graphed feasible regions by hand, and now I'm going to show you how you can start using Desmos to check your answers and to help you solve these problems. So let's jump into Desmos. Again, you can just go to desmos.com, you can Google Desmos, and you click Start Graphing. So here we are on a blank screen. To graph our feasible region, I'm going to input our constraints. So x plus 1, and we want greater than or equal to 1. So the way that you do this, I use my keyboard, and I put in the greater than sign, and then I just simply put in the equal sign. And once I type the equal sign, it says, oh, you mean to do greater than or equal to right away. So it knows what you're trying to do. And then 1. So automatically it graphs x plus 1 greater than or equal, x plus y greater than or equal to 1. And really we know what this is that it graphed. So you see how it has a y-intercept of 1, and it has a slope of -1. And it knew to graph it above the line because it's greater than. All right, next one. Let's do 3x plus y is less than, and then I'm going to type the equal sign, 9. So we don't have to do any manipulating of equations when we use Desmos. We can just put it in as is, which is really nice. So we start to see our feasible region being formed. Let's continue with that third constraint there. So we have x plus 3y is less than or equal to 9. And then we have two more constraints. We have that x is greater than or equal to 0. This is starting to get pretty crazy over there. Y is greater than or equal to 0. And that one it graphed in black, which really makes this hard to see. Notice that you can change the colors. If this kind of blurred things for you, you can simply edit, and then over on the left-hand side here, you can click on the color and you can change it if you would like. Just a heads up. Okay, so do you see how this is the most concentrated piece right here? That's our feasible region. It's this polygon outlined here. And you know, Desmos, you can click and you can get points. So there we have 0, 1. There we have 0, 3. 2.25, 2.25. 3, 0. And then 1, 0. So 1, 2, 3, 4, 5 points. And if we graphed it by hand, we would get there too. It just might take us a little longer. And this is a great way to check your work. So go ahead and take this work in Desmos and graph your feasible region here. Sketch a graph of it. And the critical points are, just as we said, 9/4 is 2.25. So there are our critical points that make up the corners or our vertices. So we can now take these critical points and we can plug them in to our objective function, and we can see which one gives us the maximum value. So we need to plug in, remember our objective function from the problem is 4x plus 28y. So we need to plug in each of these x and y's to see which one gives us the maximum value. So that would look like 4 times 0 plus 28 times 1. So the first one we get 28. I don't think that one will be our largest. So continue to do this and see what you get for your answer. Play the video when you're ready to check that. So here's what I came up with. I got 28, 84, 72, 4, and 12. So it looks like 84 is the largest value. That's the maximum. And 84 occurs at 0, 3. So there is a maximization problem using Desmos to help you.